Hey, Ombudsman students, how are you? I hope you're doing well. I hope you're staying safe. Please be safe. Stay at home as possible. Now, I'm here, as you know, because of the whole situation with the coronavirus. We have to learn online. So I thought a lot of students texted me that they don't know what to do. They don't know how to start, how to begin. Guys, don't feel too pressured. We have enough time to go over all the assignments from the beginning. So I'm going to go back from the beginning on grappling. Guys, everyone has grappling. As you see, everyone has online. And if you don't have a computer at home, if you don't have internet at home, please come to call the school and we'll schedule a time for you to come and grab a book so you can do your work on the book. So in the meantime, for the ones, I would think like almost all of you, if not all of you, have a computer at home. So make sure that you know these things. So the first thing is that we need to go to Unit 3. Unit 3 is the beginning. Most of you that were with me, we finished all of Unit 3. Now, for some of you came late, some of you didn't pass some of the assignments, so I'm gonna go back on them. So if you pass it, you don't have to watch this video. I'm going to solve the quiz in Unit 3. Of course, these are the coach lessons that I'm going over, the coach lessons in the book. So if you don't have a book, please come to the school so you can grab a book. And again, we need, of course, before coming to school, please call the school so you can schedule an appointment. It is Tuesdays and Fridays, so you can show up Tuesdays or Fridays to come grab a book. You won't be able to enter the school building, but the security guard, Derek, will tell you where to grab the book from. So let's begin. Now this first question we're going to work on is theoretical and experimental probability. I will solve the questions, then you will do the quiz in your house, on your laptops, computers, or tablets. So let's begin. Of course, I won't be solving all the questions. I will be solving some of the questions because half of the questions are the same. So we're going to solve about 6 to 7 questions tops. So let's start with the first one. Let's start with the first question. I hope you can see it. We'll see. I will check the video later to see if you can see it. So the first question is that you have this graph, guys. As you can see on the graph, we have the numbers 1, 2, 3, 4, 5, 6. Now, the question is that we need to find the probability of all the numbers that are even or not shaded. So this one is really easy. This subject is really easy. So we need all the probability, I'll write it down in case you don't see it, of even or not shaded. So when I spin this arrow, what is the probability that this arrow would stop on a number that it's even or it's not shaded? So let's see how many numbers we have that are even or not shaded. So let's begin. The numbers that are even is the 2, 4, and 6. So we have 3 numbers. Now we need to go to the numbers that are not shaded. As you can see, we have the 6. It's not shaded. I already picked it. And we have also the 3. So in total, we have 1, 2, 3, 4 numbers. We have 4 numbers. So what's the probability that the arrow would stop on one of these 4 numbers? Of course, all you need to do is divide the ones. We have 4 numbers. And we divide them by the total possibilities. How many possibilities we have in total? So how many possibilities we have in total? We have, as you can see, from 1 to 6, which means 6 numbers. So it means that the probability is 4 over 6. Of course, this fraction, we can simplify it more by dividing both numbers by the common factor, which is 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3. So the final answer will be 2/3. So the probability that this arrow would stop on one of these numbers is 2/3. I'm going to add another question just in case. What's the probability that the arrow would stop on the numbers that are greater than 3? So let's check how many numbers we have greater than 3. We have the 4, we have the 5, and we have the 6. So we have 3 numbers that are greater than 3. So I just write down 3, and we divide all these 3 possibilities on the total number of possibilities, which is 6 numbers. And of course, we need to simplify this fraction by dividing both numbers by 3, so it's going to be 1/2. So the possibility or the probability that the arrow would stop on a number that is greater than 3 is 1/2, 50% is the same. That's for the first question. Now, let's go to the second question. Guys, this is an easy subject. You can do it easily. Now this one, I hope you can see that question, hopefully. But if you can't, it's fine. I'll explain it. So just focus with me if you can't. So we have a cell phone company orders 600 new phones. So they order 600 new phones, okay? From anywhere. If the probability of a phone being defective is 3.5%. So 3.5% of these phones are what? Defective. Predict how many of the phones are likely to be defective. Round to the nearest whole number. So 3.5% of these phones are defective. So I need to find what's the probability. If I pick a random phone, it will be defective. All we need to do is multiply. So we need to take the 600 and we multiply times 3.5%. Of course, you can use a calculator or you can calculate yourself. It's the same as 600 times 3.5 divided by 100, which is divided by 100 is the same as 3.5%. 0 cancels out with the zeros. 6 times 3.5 is how much? 6 times 3 is 18. 6 times 1/2 is 3. So it's 21 phones. So the answer will be 21 phones. Again, guys, he asked us that he told us that 3.5% are defective and that we have 600 phones. So we need to find how many phones we have, and this will be the answer. Okay? Let's go to the next one. So that's another example. This is exactly like the spinner. In this, I'll solve it like fast. He wants us to find the odds of the spinner not landing on an even number. So he doesn't want it to land on an even number, only on an odd number. So what's the probability that the spinner would land on an odd number? Easy. How many odd numbers we have? We have the 1, we have the 3, and we have the 5. 3 numbers, and we divide it by how many numbers we have, which is 6. And the answer would be 1/2, 1 to 2. A cell phone company orders, now this one we also the same one that we solved in question 2, so I'm not going to solve it. Just I'm going to explain it again. So in this case we have 500 new phones and 2.6% are defective, and he's asking predict how many of the phones are likely to be defective. So all we need to do is multiply 500 times 2.6%. It's going to be about 13 phones, if I'm not mistaken. Yes. And in this case, let's solve this one together. It's not the same. The phone company orders 500 phones, 2.9% defective. All you need to do is multiply 500 times 2.9%, so you can find how many phones are defective. In this case, the spinner, the same thing, guys. You just need to understand the question and it will give you the answer. In this case, you roll a standard number cube. Find the probability of a number that is greater than 1. In this case, let's solve this one. It's also the same as the spinner. So He wants the probability of a number that is greater than 1. So in the standard number cube, we have the 1, 2, 3, 4, 5, 6. Now he needs all the numbers. What's the probability that I'm going to get a number that is greater than 1? It's these 5 numbers. So it's going to be 5 over 6, the total numbers. So the answer would be the first one. Okay? Let's do one more. Let's see, solve this one together. That's the last one, guys. We're going to solve together, so please make sure that you focus. Pay attention. The theoretical probability that a man will have some form of color blindness is 8%. Is 8%. That he might have color blindness. Whereas the theoretical probability of a woman having color blindness is 0.5%. That's for a woman. If you have a group of 700 men, predict how many will be colorblind. So he's talking, in this case, only 700 men, which means the women don't matter only in this question, okay? So we take the 8%, okay, the 8%, and we multiply it times the 700. Times the 700. And the answer would be 56. And this will be the answer. Let's go to question 10, the last one. I said 56, you go here. And it's the same thing. In this case, it's the same question. In this case, predict how many of them will be colorblind for the women. So all we do the same thing, 600 times 0.5%, and you will get your answer. So that is it for the first assignment. Wait for me to upload the second video for the second assignment, probability of multiple events. Okay, guys, stay safe. If you have any questions, please email me or please call the school phone. Thank you and have a good day.